Okay, in the first part of topic 4 here, we're going to go over domain and range of functions. The thing to remember here is that the domain of a function is all the x values, the range is all the y values. So let's look at a couple problems with mapping diagrams here. It says f of x is 3x minus 5. It's a mapping from the set S to set T as shown below. Okay, great. Whatever. Okay, find the values of P and Q. Okay, well, if we want to find P, that's the f of x value or the y value, so we just need to plug in 1 for x here. So to find P, we would do, f of 1 equals, let's see, 3 times 1 minus 5, which would be negative 2. So P is negative 2. Okay. Now, let me straighten this out a little bit. And then, okay, so, and then this one, they actually give you the y value, so you just do, 7 equals, 3x minus 5. So we can just, plus 5 on both sides. Plus 5, you get 12 equals 3x, and so x is going to equal 4. Okay? Q is 4. Okay, so those are our two answers there. All right, now let's look at the second one. A function g such that g of x is 3 over x minus 2 squared. Okay, no problem. State the domain. Okay, well, with ones like this, the only thing the domain is normally all real numbers except anything that makes the denominator here equal to 0. So if we put a 2 in here, 2 minus 2 is 0, you can't divide by 0. So, the domain of this is going to be all real numbers. Except, x equals 2, because that's what makes it equal to 0. Okay. Now, state the range of the function. Okay, now the range, the best way to do this is just really, there's a couple different ways to do it. You can sub in a really big number or a really small number like negative 1,000 or 1,000, but it's squared. Or, you can just look in the calculator, and that's what I would do on this. And so what I would do is I would turn it on, go to the y equals, and type in the equation right here. I've already done it, and then graph it. And you can see that the range, what we've got here is a vertical asymptote at x equals 2, and then, these are going down, but they're never touching 0, okay? So in terms of the range, now how do I know they're never touching 0? Well, I've looked at these before, but I can also, look here, and as, it gets larger, it's getting smaller and smaller and smaller, but it's never going to touch 0. So in that case, and then you'll see with 2 it says error. That's because that's an asymptote. Okay, so we can just say, g of x is greater than 0, because all the values of y are, or you could put y is greater than 0 also, that's acceptable. Now, write down the equation for the vertical asymptote. The vertical asymptote, like we just saw, if we go back to the calculator here, is 2. So now you have to make the equation. So anytime it's vertical, it's x equals. If it's horizontal, it's y equals. So it's x equals 2. And you're good to go. Okay, so that's the first one. Let's do another one. Okay, so for this one, it says the mapping below is of the form f of x equals a times 2 to the x power plus b. Okay, so this is an exponential function. And maps the elements of x to the elements of y. Okay, great. Lists the elements of f. Well, f is right here. Or the domain of f. The domain is right here, and the range is right here. Okay, so domain. So what are the elements of the domain? Well, it's 0, negative 2, 1, negative 1, and g. Okay. And list the elements of the range. Well, the range is just the other one. So it's negative 1, negative 1.75, 0, negative 1.5, and 30. Okay. Now, find a and b. Oh, okay, so yeah, this one can get a little tricky. But we will, find it, no problem. Okay, so what I'm going to do is I'm actually going to make, since I have an x and a y value here, I'm actually going to sub in to this equation. So what I can do here is my first point is, 0, negative 1. So I'm just going to sub that into the equation. So I would get negative 1 equals a times 2 to the 0 power. Whoa, that's not good. 2 to the 0 power plus b. Okay, and then let's take this one because that's a nice easy one. The 0.10. And so then we're going to have, 0 equals a times 2 to the first power plus b. Now I'm going to rewrite these so they're nice and neat. Negative 1 equals, now that is 2 to the first, or 2 to the 0 power is 1. So it's going to be 1a plus b. And then I'm just putting the numbers in front. And then 0 equals, 2 to the first power, so that's 2a plus b. Well, now, this is a simultaneous equation, so we can subtract and solve it. So we're going to get negative 1a equals negative 1. Okay, so, a is going to equal 1. Now, we have to sub back into one of these. We might as well go into, let's go, let's see here. Hold on just a second. Changing colors. Let's sub this into, right here, since we know a. So it's going to be negative 1 equals 1 times 1 plus b. Well, move the 1 over, and you're going to get b equals negative 2. So now we know, a and b, which is nice. Okay, and now find the value of g. Well, they give us g equals 30. Okay, so, again, that's the y value, so we'll just do 30. But now we know a and b, so we can solve this pretty easily. So we have 1a times 2x, so we just have to say 2 to the x power, plus negative 2. Okay, or minus 2. We should say minus 2. Okay, so what we'll do is we'll move the 2 over, and we will get 32 equals 2 to the x power. Now this is where there's a couple different ways to do this. Logarithms is not in the math studies curriculum, but I've taught my kids to do them in this situation where you just would do, log 32 divided by log 2, and that will give you an exponent of 5. Or you can just ask yourself what 2 to what power equals 32 and kind of go through it and guess and check. And you'll come up with the 5th power. But if you do it this way, I find that easier. Or actually another way to do it, now that I think about it, is if you don't want to do logs, is you can go into the y equals, clear this out and just do 2 to the x power, and then go to the table. And the 5th one will be 32. That's probably actually a better way to do it now that I think about it. But if you want to do logs and get a little crazy there, that's cool. Okay, so that's those are mappings, domain and range. It's a pretty straightforward concept, but you just have to be careful with asymptotes. And that's about it. So we will move on to linear functions. Okay, for part 2, we got linear functions here. Linear functions are lines that are normally expressed in the form of y equals mx plus c. You need to know how to graph them as well as be able to answer questions about them. It's also very important to be able to find the x and y intercepts. The x-intercept is when y equals 0, and the y-intercept is when x equals 0. So this takes you back to algebra. Some kids have some trouble with this. So let's look at it. A store sells bread and milk. On Tuesday, 8 loaves of bread and 5 liters of milk were sold for $21.40. And on Thursday, 6 loaves of bread, 9 loaves of milk were sold for $23.40. If B is the price of a loaf of bread, M is the price of a liter of milk, today's sales can be written as 8M plus 5M. Okay, fine. Using simple. Okay, so this is going to be a system of equations one. So we have, we have 8B plus 5M equals 2140. Okay, that is Tuesdays. Now let's look what we have for Thursday. So we have 6B plus 9M equals 2340. Okay, now this is an example of simultaneous equations where you have to use the calculator. Otherwise, you'll just take too much time. So just go to Apps, Polysimultaneous, boom, Simultaneous Equation Solver, boom, and just enter them in. So it would be 8, 5, 21.4, and then 6, 9, 23.4. And then we will solve that. What? Oh, what? Something happened. I didn't do that right. Let's look at it again. Next. Okay, 8, 5. Oh, whoa. What did I do? 640. How did I do that? I don't know. Whatever. Okay, 23.4. Okay, and then we'll solve it. Okay, so the bread is 180 and the milk is 140. Oops. Where did that calculator go? Boom. Okay, 180 and 140. So find B and M. So B equals $1.80 and M equals $1.40. Okay, now draw a sketch in the space provided to show how the prices can be found graphically. Okay, now the best way to do this, in my opinion, is first of all to map where, this is B right here, bread, where the intersection of these lines are. A system of equations is two lines and where they intersect. So, this is 180 and 140. So around right here is where these two lines will intersect. Now, what's the best way to graph these? I would use intercepts personally, and using your intercepts is really, really important. So let's graph the first one. Let's see. Hold on a second. Let's graph the first one. So what I would do is just you can do what's called the peekaboo method, where you just kind of cover this up, and you would do to find B, you would just do you do 21. Well, first of all, you got to get out of here, and then you do 2140 divided by 8, and that will give you your B or your x-intercept. So that's 2140 divided by 8. So that's 2.675. So 2.675 is like roughly like right here. Okay, and then let's find M. You would do 2140 divided by 5. And that is 4.28. So 4.28 is going to be like roughly right up here. Now it's going to go through this line right here. Now my line is going to be awful, but I'll do the best I can. Okay, boom, hit it, woo! All right, that's not bad. That's not bad. If anyone who's watched my videos before knows I'm just garbage at those. So, okay, and then let's do the other ones. 2340 divided by 6. That will give us 3.9. So 3.9 is way over here. Okay, and then what do we got? 2340 divided by 9. 2340 divided by 9 is 2.6. Okay, so 2.6 is roughly like, I don't know, like right here maybe. Okay, again, it will go through the middle. So you just go like, whoop. Oh, come on, hit the middle, hit the middle. Oh, perfect. Oh, that was getting a little wobbly there. Anyway, this is why you bring a ruler to the test. Ruler. So you don't look like this. This is not good. Okay, so anyway, if you know how to find your intercepts, it makes doing these problems when they're in, this is called standard form here, when they're in standard form, you can just graph using the intercepts. You can just use the peekaboo method. Cover here, divide them, cover here, and then cover here, divide them, cover here, divide them, cover here, divide them. So, and you should be good to go. Okay, let's do another problem involving intercepts just to kind of get the point home here. All right, so the diagram below shows line PQ, whose equation is x plus 2y equals 12. The line intercepts the axis at P and Q respectively. No problem. Okay, find the coordinates of P and Q. Okay, well, Q is going to be the x-intercept right here, so that's when y equals 0. So we'll cover this, so it's going to be x equals 12. So that point right there is 12, 0. Okay, now cover this up. It's nice. It's easier with your finger, but 2 times what equals 12? Well, 6. So this is going to be 0, 6. Okay, see how if you know the intercepts, it makes this so easy. Now, a second line with the equation x minus y equals 3 intersects PQ at point A. Okay, find the coordinates. Now, what I would do here, you can do it graphically, but it's better to do it algebraically because these equations are pretty easy. Okay, so you have x minus y equals 3. Okay, so again, you could go straight into simultaneous equation solver if you want to, but I'm just going to subtract them because this will make it go away. So 2 minus -1 would be 3y equals 9, so y is going to equal 3. Now, I need to plug it into the equation here, and so, x minus 3 equals 3. So what's x going to be? X is going to be equal to 6. Okay, so your point here where they intersect is 6, 3. Okay, so anytime they ask for coordinates, make sure you put the x and the y value. Okay, now when we get to gradient and all that kind of stuff, that's in coordinate geometry, which is, I think, topic 5 or 6, I can't remember. Topic 5, and I'm going to go over that in depth. So this is just more, when you're looking at lines and you have simultaneous equations. Simultaneous equation comes up a lot, actually. Okay, so anyway, let's move on to the next part, which is quadratic functions. Ooh, fun. Okay. All right, in section number 3, I'm going to go over quadratic functions. With quadratic functions, it's important to know that the graph is a parabola. So it looks like a U. So it's either going to be like whoop, like that, or if it's negative in front of the x squared, it's going to be like that. Okay. It has an axis of symmetry. So like it's symmetrical. Down axis of symmetry goes through the middle. Okay, the bottom, this is a minimum. It's the vertex and the maximum vertex. You must also be able to find the vertex and solve for various points on the graph. The majority of these problems can be done on the calculator. Okay, no problem. So a rectangle has dimensions of 5 plus 2x and 7 minus 2x meters. Show that the area of the rectangle can be written as 35 plus 4x minus 4x squared. Okay, no problem. If it's a rectangle, you just multiply the areas. So we'll just do 5 plus 2x times 7 minus 2x, and you're just going to expand brackets here. So let's go ahead and do that. So we get 5 times 7 is 35. 5 times negative 2x is negative 10x. Plus 14x minus 4x squared. Okay, so and then if we simplify that, we're going to get the area equals 35 plus 4x minus 4x squared. Okay, there you go. All we did was have to FOIL that one. Now the following table is a table of values for the function. Okay, here's x and here's a. Okay, okay, no problem. Calculate the values of p, q, r, and s. Okay, well this is really simple. All we have to do is look at a table of values on the calculator. Okay, so let's look. Okay, and I have already typed in the equation here, and I'm just going to go to second table, and I'm going to go through. Now it starts at x is negative 3. And I'm just negative 2, which would be 11, and then 1, which would be 35, and 2, which would be 27, and 4, which would be what? Negative 13. Okay, so hold on just one second. I'm going to write these down. Okay, so I've written down the values here, and you'll notice that this is 11, 27, 35, 35, 27, 11, negative 13. So you'll notice that it's symmetrical. Now, the vertex would be somewhere in here, and we will probably have to find that, I would venture to say. Okay, so let's look at the next part. Okay, so it says on graph paper using a scale of 1 centimeter for 1 unit on the x-axis and 1 centimeter for 5 units on the a-axis. Plot the points from your table and join them up with a smooth curve. Okay, I didn't want to waste time doing this on just because it takes forever. The way this works with IB graph paper, every box is 1 centimeter. So what you just have to do is plot the points, and you'll notice here that you're going to get a smooth curve. You're going to get a parabola here. And if you need to check it on your calculator, go ahead. This line here is from later in the problem. We're going to have to deal with that later. But, that's what it should look like. But the important point is to label your scales. So you have x right here. You have a right here. And then just follow what they say. This one goes by 1s. This one goes by 5s. And, just plot the thing. This is probably like 4 marks. So this is, an easy way to get points. Okay, so let's move on. Okay, so now they're going to ask us to analyze it. It says using the graph or otherwise. Well, I'm not even going to use the graph. I'm just going to show you how to do it algebraically. Write down the equation of the axis of symmetry. Now, the axis of symmetry is in your formula booklet. It's negative b over 2a, x equals. Okay, so it's going to be, I rewrote the original equation to put it in order. B is 4, so it's going to be negative 4 over 4 over 2, times negative 4. So, what we get here is negative 4 over negative 8, which would be negative 1/2. So, or not negative 1/2, sorry, 1/2. So x is going to be equal to 1/2. That's your axis of symmetry. And make sure you put the x equals. A lot of kids forget that. You'll lose a point. Find one value of x of the rectangle whose area is 27 meters squared. Okay, well, if we just go back up here, we have negative 1 here and we have 2 here. So I'm going to take 2 because that's easier. It's not negative. Okay, so I'll just do 2. And using this value, write down the dimensions of the rectangle. Okay, well, I'm going to actually have to go back up here and look what was it when it was factored. 5 plus 2x, 7 minus 2x. So we have 5 plus 2x and 7 minus 2x. Okay, so I'm just going to sub in 2. So 5 plus 2 times 2 equals 9. And 7 minus 2 times 2 equals 3. So the dimensions are 9 by 3 meters. And you're good to go. Okay. Okay, so and then the last part says on the same graph, draw the line equals a equals 5x plus 30. Okay. So if we're gonna do that, 5x plus 30. So you go, the y-intercept's 30. You go up 5 over 1. So they draw the line right here. Now, if you need to use your calculator to do this, go ahead. And that would be the line right there. Okay. So the way you plot lines is you plot the y-intercept here, and then you go up 5 over 1, which was the gradient, and then you draw. Or you could plot on your calculator, plot a couple points. It doesn't matter. There's a lot of ways to do it. Okay. So that's there, and hence or otherwise solve the equation 4x squared minus 4x minus 5. Now, where does this come from? What are they doing? Well, what they did is they made this equation and this equation equal to each other. So they're looking for the solutions. So, what we want to do here is we want to solve, these, where the intersections are here. We have 1 and 35, and we have negative 1 and what's negative 1? 27. Okay, so but honestly, like going off your graph is going to be a little sketchy sometimes. So I'm gonna be safe about this, and I'm gonna go to I am going to go to polysimultaneous because I just have a feeling that the IB is getting tricky on this. So I'll go to polyroot finder. Okay. And I'll go to next, and I'm just going to enter, 4, 1, and negative 5. Okay, because, if it's a decimal at all, you can't see that off a graph. Oh, wow, it was. Okay, so good thing I checked there. So, x is going to be negative 1.25 and 1. So x equals negative 1.25 and 1. Okay, so let's look back at that. So, negative 1.25. Yeah, that would have been hard to see right there. This one, and 1 would have been easy. That's not a big deal. You wouldn't be able to see that, but negative 1.25, that probably wouldn't have been easy to see. So anyway, I guess the lesson you take here is to always use the app when you're solving quadratics, and that way it will always be accurate. Okay, now that's a pretty big quadratic problem. There's a lot going on there, and it's a pretty good one. So axis of symmetry. You want to know axis of symmetry. You want to be able to enter it in. You want to be able to graph it. You want to be able to find the solutions, things like that. Okay, so there's a lot of stuff going on there. Just remember it's symmetrical, and should be good to go. And if you get in trouble, just graph it and look at the graph. Okay. And by the axis of symmetry is negative b over 2a. Find the vertex, which is the axis of symmetry, and then you would plug that x value in to get y. You can also find minimums and maximums on your calculator. And I'll do more of these problems later, I think, hopefully. Oh yeah, with calculus, we do a ton of them. So anyway, let's move on. All right, for section number 4 here, we're going to go with exponential functions. For exponential functions in the form of f of x equals a times b to the x power. A is the initial amount of the function, and b is the exponential rate. These graphs also have a horizontal asymptote as well, which is usually the x-axis unless it's shifted up or down. Okay, so these graphs are the ones that look like skateboard ramps. They look like this. Whoop! That's a negative one. Or they look like this. Positive one. Whoop! Okay, they go up real quick. Okay, so and they have normally an asymptote. So let's look at this. The number of bacteria present at any time is given by the formula 15,000 times e to the negative 0.25 t, where t is the amount of seconds and e is 2.72 to 3 significant figures. Okay, calculate a, b, and c to the nearest 100 in the table below. Okay, no problem. Again, with a lot of these problems, just go straight to your calculator. Get out of here and just go y equals, and we'll clear everything out of there, and we'll just do 15,000, and then times 2.72, and then we'll raise it to the negative 0.25 x power. Okay, and so we'll just go to the table. Okay, and let's look at this. Okay, so at 0 it's 15,000. Okay, they want it to the nearest 100. Okay, well that's to the nearest 100, so 15,000. Okay, so that's 15,000. What is, let's see, 4 would be 5,500. Okay, 5,500 to the nearest 100. The problem with this is the calculator doesn't stay up, but that's all right. And then 8 would be, let's see, nearest 100 would be 2,000, right? So that's C is going to be 2,000. So there we go. That was pretty easy. So let's see what we got going next. Okay, so part B says on graph paper using 1 centimeter for each second on the horizontal axis, 1 centimeter for each 1,000 on the vertical axis, draw and label the graph. Okay, again, I'm not going to waste time plotting points. For each box you have, you just follow exactly what they say. You plot the points and you should get, a skateboard looking ramp like that, okay? Make sure you label. Again, label is very important. That's like 2 points. A smooth curve is 1 point, and then plotting the points is normally 2 points. So that could be 5 marks for that. So you want to be real careful with that. Okay? And you can always look in your calculator to make sure you're doing it properly. Okay, so now let's look at C. Using your graph, answer the following questions. After how many seconds will there be 5,000 bacteria? Give your answer to the nearest second. So they want you to use a graph here. So it's already drawn for you here. You just go, make sure you have a ruler again. 5,000 goes straight across and straight down, and it looks to be around 4.4 seconds. Okay, so they normally give you a little leeway. So if you said 4.5, you'd be fine. Okay, now how many bacteria are after 6.8 seconds? Well, 6.8 is over here. These go by, since it's 5, it's going by 2, so it'd be the 4th box over, up and over, and that's roughly 2,700 or so. Now, it's plus or minus 200, so they give you a little leeway there, so 2,700 bacteria. Okay, so again, that's just reading a graph, so you got to make sure you make a nice graph, and just follow along, and this should be some pretty easy points for you. Now, will there be a time when there's no bacteria left? Well, technically no, because 0 is going to be, if you looked at this graph, if we went back to the calculator, and we looked at the, let's just keep going down here. Look, the numbers keep going down, and it keeps going towards 0, but it's never going to get to 0. Now, in real life, is that true? Probably not, but in this case, theoretically, will there be time? No. The answer is no, because 0 is a horizontal asymptote. Okay, so technically it gets closer and closer and closer, but it never gets there. Okay. So anyway, I mean, my kids tend to do pretty well on exponential functions. And you know, graphing them, just be careful. Just follow what they say, and you should be all right. Okay, I'm going to do one more problem on this. Okay, so this problem is more about you know, just reading a graph, an exponential graph. So let's look at it. The graph shows the temperature in degrees Celsius of Leonie's cup of hot chocolate t minutes after pouring it. Equation of the graph is f of t equals 21 plus 77 to 0.8 t power, where f of t is temperature and t is minutes. Okay, no problem. Exponential function here. So we have a. Find the initial temperature of the hot chocolate. Well, that's, you know, would be when t equals 0. So we'll just do f of 0 equals 21 plus 77 times 0.8 to the 0 power. No, that's 0 here. Now anything to the 0 power is 1, so this is really just going to be 21 plus 77, which is 98 degrees. Okay, so yeah, that was a boy band in the 80s, 90s, 98 degrees, I don't know. Okay, write down the equation of the horizontal asymptote. Now the horizontal asymptote is always the number that's after the exponent there or before it. In this case it's 21. So they want the equation. Now if it's a horizontal line, it's going to be y equals. So y equals 21 here. As for C, write down the room temperature. Well, the room temperature is just going to be the horizontal asymptote here, which is, you know, 21 degrees. Now finally, you know, find the temperature of the hot chocolate after 8 minutes. This is another one of those things where you have to look at the graph. You see that 8 minutes is right here. You know, you're going to go up, and then again with a ruler, you're going to go over. And my line's not that straight, but you get the point. It's basically around 35 degrees, and they give you a little bit of leeway on those. Okay, so what you need to be able to take out of, you know, these problems are you need to be able to graph them, you know, fill in a table of values, you know, look horizontal asymptotes, and you know, be able to write the equation for that. And you know, read the graph as well. And if you can do that, you are good to go. Okay, so let's move on to sine and cosine functions. That will be the last section in this one. Okay, what we're going to do in this video is we're going to go over some basic sine and cosine functions and a couple problems that deal with these. Now the first problem here we have is a sine curve, okay? And the important thing to know about a sine curve here is it always, you know, it's going to start right here. Well, you know, if it isn't shifted, it starts at 0. It goes up to 90 to 180 to 270 to 360. Now it's periodic, which means, you know, it repeats. It goes on and it keeps going on forever. Now there's a couple terms that you need to know here. Let's see, let's get some color here. For instance, okay, so this, you know, like this right here from the top to this middle part right here is called the principal axis. Principal axis. Okay. Now the amount it goes up and down is called the amplitude. Now you can stretch amplitude, and that should be a D, whatever. It can stretch up, like this could stretch up to 2 and down to -2, for instance. And then, you know, the amount of time it takes to, you know, for it to repeat is called the period. So in this case, the period is 360 degrees. Now you can shift these whole things. Now the way, you know, a sine function is written would be like this. Y equals a sine bx plus c. Now a is the amplitude. Well, that's easy to remember. B is basically how many periods are in 360 degrees is the way I always look at it. So for instance, if this were 2, there would be 2 periods in 360 degrees, so the period would be 180 degrees. So this has to do with the period right here. And then this C is the vertical translation. So, you know, you can move these graphs up and down. Okay.
Now, here we have a cosine function. Now, the only difference with the cosine function is it starts at the top of the function, as opposed to starting right here. It starts at the top. Okay, so basically what happens is you can shift a lot of these, and we'll do a couple problems where you can kind of see how that works. So let's move down here. Well, look, if you look at this, you can see actually the cosine and sine functions on top of each other. It's pretty cool. Like, basically all you can see is that they're just shifted 90 degrees. I mean, they're the same function aside from being shifted 90 degrees. And if we were to look at a unit circle, you could see that. In the studies curriculum, you don't really have to know the unit circle, so I'm not going to get into that. But just know the cosine starts at the top. Sine function starts in the middle of the periodic function. So let's look at this problem right here. It says the temperature in degrees Celsius during a 24-hour period is shown on the graph and is given by the function f of t is a cosine bt plus c, where a, b, and c are constants. T is the time in hours, and bt is measured in degrees. Okay, we can do that, no problem. Okay, so this is a very typical problem. You'll have to figure out what A, B, and C are. So we can do that. It's pretty straightforward. Okay, so this is actually a really neat problem in terms of, it does all the things we were just talking about in terms of shifts and periods and all that stuff. So basically what I always like to do here is, kind of look at the top of the function and look at the bottom, like right here. Okay. Now it says it's cosine, so we know it's cosine, and it starts up at the top. That's fine. Now the maximum here is -1, and the minimum is -5. Okay. So if we want to find out, what the principal axis is, we can just add those together. So like -1 plus -5, and just divide it by 2. So we basically take the average. So it'd be -6 over 2, which is -3. So basically what you're looking at here is the principal axis is at -3. It's really important that you get the principal axis. Once you get that, everything else is pretty easy. Okay, so the first thing they ask us is, they want A here. Well, okay, no problem. That's the amplitude. How much does it go up or down from the principal axis? Okay, well, 1, 2, 1, 2. So that number is 2 right there. Okay, because, this is going up 2 right here. This is going down 2 right here. Okay, let's see. Find the value of B. Okay, well, this isn't done in degrees. It's done in 24-hour periods. Now, it takes 24 hours for, one period. So what we need to do is translate that to degrees. So the way you do that is you just take 360 and you divide it by 24, and that equals 15. So that's going to be your number that goes in front of the t right here. And then we want to write down our value of c. Well, the value of c shouldn't be that difficult because we've already gone through it here. We've already found the principal axis. So, the principal axis always, just a normal function starts at 0. Well, it went down to -3. So this is going to be -3 right there. So if you were to write this equation out, it doesn't ask you to do that, but it would be, oh, well, they say f of t. I was going to say y. So it would be f of t equals 2 cosine 15t minus 3. That's the equation of it. And, that's basically how you do it. Now, it says write down the interval of time during which the temperature is increasing from -4 Celsius to -2 Celsius. Well, let's look for -4 Celsius. Well, -4 right here, the temperature is going down. We don't want that. We want it going up. So from -4 up to -2. Okay, so it's going, 16 to 20. Okay, so we don't really know if this is starting at midnight, or I would assume it starts at midnight, but it doesn't really matter. So we're just going to do t, and let's see, is increasing from -4. So t is going to be greater than or equal to 16, but less than or equal to 20. And, you could also write it down like this if you wanted to in brackets. But I would write it down as an inequality like this. And they always ask one inequality, one like that. So there you go. That's a cosine function that has, amplitude, it has the period, it has, the vertical translation, and you had to actually look at the graph and see what was going on. So that's a pretty good problem. And now we'll do one with sine. Okay, this is a sine function, and it says the graph of the function f of x equals a sine b of x plus c is shown below from negative 360 to 1080 degrees. Okay, so what this is doing, this is in degrees, which is nice. It's a little different than the other one, so it shows you kind of both ways these problems work. All right, so what they want us to know, and this is a sine function, okay, so this is going to start, do I have a pen here? Let's see here. This is going to start right here, the sine function. Whoops. All right. Still pasting stuff. So okay, so it's going to start right here. So one whole period. Well, it goes up and down and back up. So okay, this is kind of stretched out a little bit. So instead of it being normally like 360, this period here is 720. So when they say write down the period, they want the total length. So that would be 720 degrees. Okay. Now let's see. Write down the values of A, B, and C. Okay, cool, no problem. So again, I'll do the same thing I did on the last one. Let's just look at the top of the function right here. The maximum is going to be 5, and what's the minimum? The minimum is -1. Okay, so what I want is the principal axis. Well, I think you guys can see where it is, but, let's do it anyway. 5 plus -1 is 4, divided by 2 is 2. So the principal axis is right here. Okay? Once I get that, and I mean, you can see this on a graph. All you have to do is stick it in the middle. And they usually give pretty nice graphs here. Now, what we want to do is look for the translation here. So let's look at that. Or excuse me, not the translation, the amplitude. So let's look at that right there. Okay, well, how many spaces is that? 1, 2, 3. Okay, so the amplitude is going to be 3. Okay, now write down the value of B. Okay, well, B right here. Okay, well, let's see. What do we have to do here? Well, the period takes 720 degrees, so we can just do, just like we did on the last problem, we just do, let's see, where can I put this? Running out of room, I'm running out of room. You could just do, 360 divided by 720, which is 1/2, okay, so, or 0.5, but I would put 1/2. It doesn't even matter. So that's going to be your B right there. So again, you just divide by 360. And then, what else? C. Okay, well, how much did it get translated? Well, the principal axis starts at 0, and it went up to 2. So this answer is going to be 2 right here. So if we were to write, they don't ask you to do this, but if we were to write this, oh, it's f of x. Gosh, I always mess that up. F of x equals, it would be 3 sine 1/2 x plus 2. And you are good to go. Okay, now, then of course they always, once you write the equation, they always ask you to analyze it a little bit, which we can certainly do here, not a big deal. Okay, so it says P is one of the points where the y equals f of x intersects the x-axis. Okay, so we're looking for the x-axis here. Lies between -180 and 180. Okay, so where it crosses the x-axis between -180 and 180 is going to be right here. Okay, so it says mark and label the point P on the graph. Well, okay, no problem. P, there you go. And then estimate the x-coordinate of P. Well, what does this look like to you? I mean, you have 0 here, you have 180 here, so this cuts it in half. So I would say this is, roughly negative 90 degrees. Now, it's a little bit over, maybe. They give you all the way up to 80 on the mark scheme. So I would say negative 90 degrees. All right, so that pretty much does it for that. So anyway, I hope this video helped you out, and we will leave on one last note here, because I'm a basketball coach, so I have to show this. This is rad. Okay, 1 second. Hold on. Okay, check this out. This is the best free throw you'll ever see. Oh. Oh man, that's not right. All right. Have a good day. Take it easy. Bye-bye.